Okay, so for number 22, it's nice that they wrote out the natural decay function. They told us that we needed to use that. And we've been told that the half-life of carbon-14 is 5730 years. So that means that the 50% of the initial amount will decay in 5730 years. So that's what we're going to need to plug into this equation right here. Okay, so here's the idea though. If 50% of it is left, suppose you put a 1 in here. Suppose you'd say there was 1 initially. Well, then that means there's going to be 0.5 here. So essentially what we're saying here is that this percent actually does tell us exactly what's going on here. So let's write this out here. I'm just substituting 0.5 in here for this, and then my initial amount is 1, okay, which I'm just going to treat that as an understood one. And then we have e to the negative. We don't know the k value, so but we do know the time, which is 5730. So 5730, and now we can do something kind of clever. Remember, if you have the same, if you have an equality here, you can, as long as you do the same thing to both sides of the equal sign, it's completely legal. So what we're going to do is take the natural log of both sides. So we take the natural log of this and the natural log of this, we get negative, and I'm going to put this in a little more, less awkward position. The k should be in the back. Okay, so now I've taken the natural log of both sides. Do you remember that if you have the natural log, the understood base is e, okay? So that essentially what this is saying is, I'm going to use an example over here, natural log of 7, natural log of e, and if you have e to the 7th power, okay? So what would this be? E, what would this have to be? Well, it would have to equal 7, because e to the 7th power equals e to the 7th power. So the base raised to the exponent gives you this number right here. So this whole thing equals 7. In other words, it equals whatever is right here if these two values are the same. So what we can say about this whole piece right here is that it equals this. So I'm going to say equals negative 5730k, and then we have the natural log of 0.5, divide both sides by negative 5730, negative 5730, and I'm thinking that for k, you should get kind of an ugly number. I changed it to scientific notation, so I got negative 1.21 times 10 to the negative 4th, okay? Now, the problem is we're not done, okay? So now we have to use this. We know the constant now. We have to use this to find out how long it will take for 51% of an initial amount to decay. Okay, so that means when you're done, the amount that you have left, the amount after time t, is going to be 0.49 because it's 100% minus 51%. You get it? Okay, so 0.49. Again, the initial amount is considered just 1 because we're talking about, you know, the whole portion, and now we have only 49% left. So we have e to the negative, and then that's going to give us this whole big mess here. K is negative 1.21 times 10 to the negative 4th and time t. Okay, so now we're going to take the natural log of both sides, just like we did a second ago. Natural log of both sides. And we get negative 1.21 times 10 to the negative 4th t. When we take the natural log of both sides, now we have this equals negative 1.21 times 10 to the negative 4th t equals the natural log of 0.49. Now you can solve for t by dividing both sides by negative 1.21 times 10 to the negative 4th. Do the same thing over here. You get negative 1.21 times 10 to the negative 4th. You solve for t, and you should end up with 5,895 years. Okay? I hope that was helpful for all of you.